Hi, I'm Stuart from Leaskspec. I wanted to take some time today to show you the process of what I do whenever I go through the RB26 oil pan modification. I'm gonna treat this as kind of like a dual purpose video. What I want to do is share my process and share my fabrication steps, and maybe that might help you a little bit for people who are kind of doing this for the first time. But I also kind of want to do this to further explain my product, how it fits, and the benefits to purchasing the template kit pictured here, and some of the other, basically the steps of the process. So to begin, obviously we have three pieces. This is the extension kit that you'll get when you purchase from me. That's really hot right now. This is the template kit. Everything can be ordered through the TF Works website. This can be purchased together as a package. They also offer a package with a baffle kit inside the oil pan, and I'll kind of explain that later. Here is a pan. It's actually a great pan. For example, this user ended up vapor blasting it before I started. Do not feel like you have to do this. I can do this on used pans, but ultimately I can accept them in any condition. Just if you send me something that's full of oil and really rank, there will be a slight cleanup fee added, as I do have to prep it to an extent for welding. It's already tough welding cast aluminum. So the first steps that we take, and this is gonna be a little bit different than some products. As you can see, the differential is gutted on this. Don't feel like you have to gut the differential on your oil pan. I cut and weld these things with the differentials installed all the time. I take careful care to plug the input for the driver's side axle, and I plug up everything in the pan so that you don't have a huge mess of oil shavings and then you've got to disassemble it anyways. So that being said, I can save you the money of having to do a differential build if you don't feel like you need to do that. But if you would like to do that, I can also sort out and organize having your differential rebuilt, new seals. I offer ATS carbon LSDs and various other upgrades. So to start, what I like to do is I kind of reality check the situation. And what I mean by that is not everything is 1000% accurate to the template to the T. There can be some variance in the machine shops, etc. So what I like to do is I get a good measurement right along here. Typically I'm at about 5 5/8, and that looks to be exactly what this one landed at here. So what I do then is I click the template on. You can piece this together on the pan, but if you remove the drain bolt, you can kind of just slide it over. It's got just a little bit of play and a little bit of flex. So you'll be locked in on two places. One, you're gonna notice that there's room for the teeth right here. And you see that good fit on the corner. That's an important concept right there, or rather it's an important locator, not concept. You'll see down inside this wall. And then on the other side, you'll notice that we aren't quite pressed in yet, but just to show you, there's two locator fingers. And those fingers should actually be slipped into the bolt holes. And once you do that, you'll be able to relax the template down onto the pan. So those are located. This is located. This is nice and tight. You can see it's got a good grab all the way here, here, and here. Now, the next stage. A lot of people ask me, where am I supposed to actually make a line on the template? And that's a great question, because quite honestly, you could think about doing it on the outside, etc. So it's supposed to be on the inside of the template, from interior to interior. And like I said, we took that 5 5/8 dimension right here. So what I do is I just go through and I just double check that my template is sitting at 5 5/8 relaxed, and it is exactly. So I'm safe to go ahead and make my marks after I reality check the situation. And what I mean by that is make sure that because these were cast pans and they were done in multiple generations, so there could be some very slight skewing or shifting. So this is kind of up to you, the fabricator, to make sure that there's nothing obvious that you're missing. So go ahead and make our marks right there. And then I make it right here on this vertical wall. Sorry, it's behind the camera. Go ahead and do it right there, and then right there. And what I meant by reality check, let me revisit that concept real fast, is just making sure that it's kind of sitting straight and in line with the pan. The other very important line that we'll figure out here in a second is this front cut right here. So what you'll do is you'll get the Sharpie as far down in there as the Sharpie will go, but then the Sharpie won't get completely, mostly just because the tip. And this is okay, because I'll show you a trick in a second that I like to use. Go ahead and mark the lines along the top. Mark lines along the top. Lines along the top. And then along there. All right, so you'll see that once I've done that, I'm not quite up to the back side of this template, and that's fine, because moving forward, what I'd like to do is I want to take my measurements with this template off from here and mark out my true 5 5/8. Make sure that these lines are running square, that they didn't skew in either or direction, and that it looks good along the face of the oil pan, because that's going to determine kind of how the extension tilts or sits on the pan. So now that we've got everything marked, this is safe to go ahead and remove. And that's kind of what you're left with. So, as mentioned before, the first thing I do is I just go ahead and I check how close am I to 5 5/8. I'm about a 1/16 out. So, I'll check the face of it and make sure that this line is level with this body. And you can, here, I'll probably go ahead and rotate that so that you can see it a little clearer. You kind of see, you're gonna have to eagle eye it a little bit, but this should plane out perfect with this. If it's not, that's fine, because with this line, you still have a 1/16 to play with. With mine, it looked like it leveled out just about perfectly, except for here. But if you'll remember, that's where the bridge was for the actual template, so the Sharpie couldn't get down in there. So what I'm gonna do when I cut is I'm just gonna cut this a little bit heavy on the left side of the line, and that should buy me back my 1/16. Everything else looks straight and good to go. So I'm gonna go ahead and get to cutting, and I'm gonna show you the order that I cut it in, what I use as like a home base marker where my first cut is, and what I base everything else off of from there. The first most important thing is this is the point that I don't change at all right here. So as far as my order of cuts are concerned, this is where I start. I start right here, I grab this 45, and then I grab this wall right here. Just note that inside there are multiple mounting points for the baffle plate that mount inside the pan. It's controversial, and quite honestly, I think that most people are fine. This one can go, I leave it. I have a certain fabrication process that I'll show you, but I like leaving this one. When you make the cuts on the lines that I've got marked here from my template, you'll cut through this one, but you'll still leave about a good 12 millimeters, maybe 10 millimeters worth of thread. So this one doesn't actually become unusable. And you'll find that you kind of just bite into the sidewall of this one. Everything else should remain largely untouched. So I'm gonna go ahead and start cutting. I'll show you the process and the order that I cut in. The tools and equipment that I use is just stuff that I have found that works best for me over time. Don't feel like you have to use it. You'll probably have a laugh at the 7-inch wheel on the 4.5-inch grinder. It is what it is. I've tried a bunch of different things, and I still find this to be the fastest. So I guess with that being said, I'll go ahead and start the fun part. You should have kind of just grazed the little bit of this wall. I like to leave the integrity of this entire column. You'll just kind of graze right against the side of it. You should have just a little bit left over on this wall. Now the most important part is your front to back measurement should be the same as your extension. So for those that didn't see it before, what I do is I use this extension as my guide once I've laid my template lines, because the template lines are an incredible starting point. But at the end of the day, this is what you're actually welding on. So very carefully, hopefully without adding much scratches, what I like to do is I like to just double check. That's about 5 5/8 exactly. They usually are, but sometimes there can be some slight variances. And then I just go ahead and check. Now that I have one line for sure, I just measure out 5 5/8 against it. And you'll notice that I'm about a 1/16 over my actual Sharpie line right there. So I'm sitting at about 9/16. So if I cut heavy on that line, That should put me at the right spot, and then I just double check it front to back and make sure that that is the same situation all the way across. Okay, not all of that is completely final, but that should be close enough to get us in the vicinity. So as you can see, I cut heavy on this marker line. This is good as the template directed, and this is good right here. So now we start working on this part. This part is actually a lot of the reason why I use one of these larger wheels, because cutting through these fingers can kind of take some time if you're not strategic about it. Right here is the pocket that the template likes to sit in, and it's very, very hard to get a Sharpie in there. So because there is a little bit of variance in the casting from pan to pan, I like to recommend that you cut real close and short along the fingers. Right up here, I got the Sharpie in there, but it was a little bit shallow. I knew that it was about a 16th off, just about as it was all the way around here. So I know to cut this one a little bit heavy, and you can kind of see I'm on the heavy side of that line right there. So I'm going to continue upwards. I'll go ahead and cut these fingers off. Then we'll start reality checking everything to the actual extension. And then from there, all the trimming and the final orientation and the detail work gets done, extension to pan. Okay, so now that you're finished with the final cuts, you should have a piece remaining that looks something like this, give or take. Could be in more pieces or whatever, that's irrelevant. Now we need to finish getting the rest of everything set up. Some people will opt to leave these fingers. There's absolutely nothing wrong with that. It's a decent idea because there's good support, but I make sure that all of my material is 1/8 inch. So the extensions themselves are pretty strong. Me personally, I actually like getting rid of these. I haven't found a method of cleaning these up to make them weld very good, in my opinion. So I typically skip them and get rid of them. As mentioned, I like to keep this. So what I'll do now is I'll kind of just shave all this flat, kind of cut in a little bit of opening so oil can flow freely to this side. I'll get rid of the fingers and I'll start rough test fitting the extension to the pan. There's no situation that exists where the extension doesn't need a little bit of cutting and trimming of its own. As you can see, when I make the product, I actually purposely leave a little bit of overlap, and that's because we'll probably be cutting it along this line, give or take. And just about the same with this, and there will be a little bit of cutting on this wall always. So I'll kind of show you where this ends up getting cut, where it ends up getting adjusted, where I adjust the pan, and some of the final stages of fitment before we can get ready to tack it up, fixture the pan, and weld it. I guess that signifies the end of our taping process. See all the tape that we get today. I'm gonna put a little bit more right there. All right, so now you should have a situation that kind of looks like this. In my instance, I go ahead and shave off the fingers, as I had mentioned before. In my instance, I make sure to leave this baffle screw hole. You can or you cannot leave that. That's completely up to you. You can cut this a little bit lower. I found that this is pretty adequate flow, and I don't really see any restriction in it, personally. So all of this is just rough cut. I haven't beveled, I haven't chamfered any edges, and I haven't started final prepping for welding, and that's because now we have to fit the two together. What I've done is I've kind of just taped over the extension, because as I mentioned earlier, the extensions are not made to just drop right in. So what I'm gonna have to do is I'm gonna slowly kind of slip this in and out, and I'm gonna have to start marking along this top edge so that I can get a good contour profile and get a good meetup somewhere around right here. And I'm gonna have to do the same on the bottom side. As you can see, there's still some coming through there. Again, I like to leave this screw hole, so I choose to cut the extension and just weld it to the wall and leave the strength of this here as it is. I've seen people cut this off, cut this wall higher so that this can sit up, and then they get a nice inside weld right there. I think that that's perfectly acceptable. I don't think that there's a right or a wrong way. This is just the way that I've kind of taught myself over the years, and this is what I prefer to do. So this is going to be the way that I show you in this particular video. But it's like it's an order of process. So basically you're just kind of trying to find what hits first and what hits the worst. And yeah, that does seem to be, that needs to go back, that needs to go back. So double check the line. And of course, all these edges get cleaned up later, but for right now, all we're concerned with is the test fit. So we just need to make sure that we've got this thing fitting and complying in the pan good. All right, now that is hitting. Okay, so I've got this side going. That's good. All that's good. Okay, so now I need this corner. And so the last thing that I'm gonna do before I weld the extension itself on, now that I've kind of cleaned all the welding surfaces and gotten everything prepped and ready to go, I go ahead and drill out these drain backs, but I do it on all the pans that I leave my shop. So I'm just choosing to do it now, get this done, kind of clean out the lubricant that I used, give this a good wipe down with acetone. Same thing with the extension. Even though it's raw aluminum, it could have gotten any sort of grease or anything when I was cutting it. I'll bolt this to the fixture that I typically use that keeps it straight during welding, and then I'll tack that on and I'll kind of show you guys all that process next. And we do this so that the oil that gets returned back here into the rear of the sump can kind of drain back down into the pickup part of the sump as quickly and as easily as possible. Okay, so now that everything's fitted up, I've gone through, I've cleaned the edges of all of my welding surfaces. I've put a chamfer on every welding surface so that all of these welds can get good penetration. And so I've gone ahead and I've installed what you see here, which is my fixture plate. And I do this for a couple of reasons. A, it kind of does a decent job of drawing the heat out of the aluminum. And B, it stops the flange from warping during the welding process. I've seen some of these pans come back to me after being welded in various different ways where they kind of have like a little bit of a high spot. I know that it's bolted up with all M8 bolts, so for the most part it would probably draw back to straight, but this kind of helps me ensure that it's as straight as possible. Sometimes you'll still get a little bit of warping, but that's just kind of part of it. Another alternative you can do is you can take an old blown up RB and you can kind of just cut the bottom half off and use it to weld. But as you'll see coming up, I also use this to pressure test my pan welds. So it's important for me that this is a perfect seal, whereas you can't get that by using the bottom half of a block. Anyways, without rambling much more, I'm gonna go ahead and give this one more good wipe with acetone. It's always important that your aluminum and material that you're welding is as clean as possible. I'm gonna give it one more wipe with acetone, make sure that I didn't miss anything, tack weld, and go ahead and final weld the outside. And then once it's cooled off, I'll take off this flange, or rather the fixture, and do a good weld along the inside, let it cool off, and then pressure test it. So let me kind of show you some of the steps involved in those processes. Okay, and easy as that. So it's welded in. What I'll do now is I'll let this get to a reasonable temperature. Like I mentioned before, my fixture also does a pretty good job of drawing the heat out of the aluminum. So once I feel like this is cool enough, I'll go ahead and unbolt the fixture, and I'll get inside the oil pan, and I'll go ahead and weld all the way around inside as well. And then once I'm done with that, I'll put the fixture back on, and then I'll kind of show you guys my steps that I take to pressure test and leak test the welds, as well as the rest of the oil pan, because there could be mysteries everywhere. They're old parts, and yeah, so for now I'm just gonna watch the clock run out and wait for this to cool down. I'll save it for in case I'm wrong. Hopefully I'm wrong. All right, now that I've finished welding the inside of the pan, at least the edges that are accessible, I'm going to go ahead and put all of the pressure test pieces on. This one is disassembled because it was vapor blasted. So what I do is I use these bushings to kind of plug off where the half shaft, I guess we'll call it the half shaft tube, originally ran through. I'll go ahead and tighten these up. You can see that I've put the plugs on the NPT fittings on the top of the pan wing. I put a Schrader valve here for air inlet, and then I went ahead and put the drain plug on. So once all this is done, the pan should be completely sealed, and then I will go ahead and toss on a gasket that I had made, and I will put my fixture plate right back on top of it, bolt it up nice and tight, torque it, and put some PSI in this thing and check it for leaks with soapy water. All right, so now that everything's sealed up on the pan, I've got the fixture plate on, the gasket on, all the plugs, everything should be sealed up. I'm gonna go ahead and pressure test it, and usually I give it around like 20 to 25 PSI. It's 1/8 inch wall construction, so it shouldn't be any problems as far as like ballooning the sump. But the reason I do such a high PSI is because that's a good test for air leaks. You're gonna see that come through with soap and bubbles like very quickly, very easily. So I guess without further ado, let's go ahead and put some pressure in it. So even though I'm confident in my welding and my fabrication, I still like to check all of the joints of the expansion tank itself. Like that. All right, and that's it. So everything pressure tested, held about 25 PSI. I did about 3 rounds of soap, water, check, make sure everything's good. I'll go ahead and sell it, or rather return it to the customer with plugs in the pan, drain plug intact. The drain back's drilled out and everything's said and done with the extension. One more thing that I did want to point out that is kind of an off-camera deal, but it's something that I offer specific with my services, is any pan that comes through for extension work or modification receives a serial number. You'll see that this one is LS012. And I also mark any pieces that can come off of the pan, so you'll see that this is 012 as well. The reason I do this is because sometimes I submit more than one pan to vapor blasting at a time, and I want to make sure that the flanges stay with the pans that they were intended for. But I also do it so that I can notate in my system different facts about the pan. Like if there was any variance in the shim bearing or the shims for the bearings inside the pan, if there was any sort of damage that I noted with the pan, if there was a cracked fin, or if there was any other issues, if there were missing pieces, what final drive it had, if it had a 358, if it had a 411. And that's a good way for me to keep a system. And also I save a video of me pressure testing that pan in my documents. So I know that if anything ever happens with LS012, if there's ever a question, I can pull up the video of the pressure test, all of the information that I had about it before breakdown, the list of all the parts that went into it, the modifications that I did, so on, etc. So there's full documentation of everything that goes through the shop. Anyways, that's my process start to finish. If you have any questions or if you have any interest in this service for me, I offer a unique package where I will do a core exchange program. I understand that for a lot of people, it's a big hassle to take these pans off, send them out for, possibly weeks at a time, have them worked on, etc. Some people can't afford that kind of downtime. So what I do is I stock oil pans that are factory. And for those interested, I will do the extension and modification service. I can vapor blast it. I can do whatever I need to do, ship it to you with a core charge, and then you can ship me yours back as long as it's in good condition with no damage or no issues. So hopefully that's something that will help some people out there with downtime or anything else. And if you have any questions, comments, if you're interested in any work, if you have another pan extension that you prefer over mine, and if you need the welding and fabrication work done on it, I'm happy to do that too. So just leave me a comment or shoot me a DM or anything along those lines, and I'd be happy to help. Anyways, thank you for watching.